All right, hello. Welcome. Thank you for coming tonight. This is the first installment of Protocol NYC. Woo! Yeah! It's gonna be fun. It's gonna be a fun night, I promise. So this is called the Blockchain Showcase, and we're gonna talk about later why it's the Blockchain Showcase. And tonight will be hosted by me. My name is Dan Zimmerman. So a quick little thing about, like why would someone want to put on something like this? And how many here know about Bitcoin? Right? Everyone here has heard of Bitcoin? All right, does everyone heard of a blockchain? Right? And people know the difference between the two. All right, those are really easy ones, right? Now, has anyone heard of a DAG? All right, this is pretty good. All right, I don't know what holochain is, so I can't really explain it. But what's really fascinating about this new space that's coming about is that there are many different blockchains, right? There are hundreds of different blockchains. And what I think it's really important that we kind of look at them and survey them closely is that blockchains have very different characteristics. They have different reasons for existing. They have different morals, if you will, right? They have different qualities. And each one kind of depicts a different future, right? Or a different reason for existing. So at Protocol NYC Blockchain Showcase, what we're doing and what we're going to be doing in the future is that we want to take projects that are maybe somewhat similar, group them together, and then look and see how they're different, how they're similar, how they relate, and then kind of bounce them off each other. This is really a great opportunity for one. We have some projects that are international, so they're not usually here in the States. So we've got 3 tonight, and we'll be talking about them. The first one, so if you want to be following along, all these different things, NYC Protocol, if you want to follow the different projects, Phantom, Holochain, IOTA, and then if you want to do a little Twitter thing, there's the Protocol NYC thing. So there's 3 projects that we're going to be looking at tonight. One is called Phantom, which they're going to explain later is actually not a blockchain. Would you say that's correct? Would you call yourself a blockchain? Okay. Okay. Well, there's a reason I brought us all together. There's Holochain, which also doesn't consider itself a blockchain. And then there's IOTA, which is going to be represented by the IOTA Evangelist Network. And what's really exciting about these is that we all kind of seen this evolution of different projects, right? So first there was Bitcoin. Everyone knows it's kind of pluses and minuses. And then Ethereum came out, right? Where you could build smart contracts on top. And we all know that there are some limitations with Ethereum currently, and there's a hope that those will be achieved, fixed at some point. But with that wave, there's now this whole new cohort of projects, I call them projects, that have come out that aren't blockchains, but that want to fix a lot of the problems that are inherent in a blockchain-based, I want to call it design. So what these 3 have in common, but what also makes them so unique, is that they're not blockchain-based. So they're distributed ledgers that might have different characteristics. They might not be linear blocks of transactions, but they might handle their transactions differently. So it's going to be exciting to kind of hear how they explain themselves and how they compare and contrast themselves to what we're kind of familiar with. The other thing, too, which I think is really important, and this is kind of a characteristic of, it's why I call these things projects, is that, when you look at a lot of different, things on CoinMarketCap, right? A lot of different projects, some of those are products. Some of them are platforms. Some of them are just currencies. What's really cool here is that we're looking at, for tonight, just base layer protocols. So these are protocols with the intention of having other products, services, platforms built on top of them. And I think that that's really important because, like I said, when you're looking at a base layer protocol, they all have different kind of mechanisms and reasons for existing. So it's really cool to kind of bring them together and have this opportunity to see how they bounce off each other. So with that, we're going to do that for about 20 minutes each, maybe 25 minutes. You want to do, you said 2 hours for yours? Okay, he wants to have a long one. And then we're going to do what I'm calling a friendly Q&A. So you're going to get to ask questions. We have people streaming online from the Phantom community and from the Holochain community, and they're going to be asking questions virtually. And this is just a cool opportunity to kind of ask and compare and contrast projects. And then at the end, we'll save some time so we can all kind of chat and connect with each other. So with that, let's hop right into it. Our first project tonight is going to be Phantom. So, woo! I did not get the memo about no shoes. This is okay. Well,
you want me to multitask here? This is not what I was designed for, but let's see how far we get. So it was designed for fast consensus in localized distributed networks. So an example of that is automated cars in a non-traffic environment. Why do we have traffic lights? Because the cars need some way to instruct each other. I need to stop, I can go, you need to stop, I can go, etc. So if you remove the traffic lights and you want all of the cars to be able to interact with each other and in that localized cluster make decisions with malicious parties potentially, you need some way for them to very quickly communicate to each other in real time and arrive at decisions. So if you can do that, all of a sudden you can imagine all of these cars moving at 100 miles an hour crossing these intersections because they know the information from the other vehicles that they're going to be interacting with. So it started off with this premise, and it led itself nicely at the time to a lot of research that was going on in this area, which is specifically surrounding consensus and the problems with it. As mentioned, you have Bitcoin, you have Ethereum, you have all of these front runners who as a design mechanism, and there's a reason they were designed that way, but as a design mechanism, they're fairly slow and cumbersome. Bitcoin, your average transaction is going to be 10 minutes. And if you want to have statistical finality, you're going to be waiting around 30 minutes, 3 blocks, give or take. Ethereum, 30 seconds per, so it's about 60 blocks for real finalization. Did I do something wrong here now? No, but I'm not on. I could have definitely messed it up. And I don't think this way, okay, it's the one. All right, there we go. Thanks, man. So Phantom is, and this is where there's an interesting distinction, because people often, there's block, and this is why I mentioned, Dan, that I have a little segment on this. It's actually a little bit later, but I'll just mention on it now. Is because there's blockchain as a data structure, which is a block that points to another block with a hash to the previous hash. And then there's blockchain, the category. Technically, all of these cryptocurrency blockchains are part of the blockchain category. And I say that specifically because we're talking about high scalability DAGs. I saw earlier there were quite a few hands on DAGs. I'll have a little bit on it in a little section. But Bitcoin is a DAG. I mean, Bitcoin is a directed, acyclic, can only go from the one section to the another section graph. So even though nowadays we have all of these DAG protocols coming out and everyone's making a scene about DAGs, Bitcoin's a DAG, Ethereum's a DAG, all of them are a DAG structure. So as far as the classification of a data structure goes, all of this stuff is DAG, but they all form part of the blockchain category, not necessarily the structure. But now I'm going on into a little bit nomenclature. So it's got this high scalability DAG, which I'll explain in a little bit. Then on a different research side, this is more from University of Sydney and the guys in Australia. There's the secondary problem to something like Ethereum, in that its original goal was this world supercomputer. It's so that you have the combined resources of all of the participants in the network. What we've seen with proof of work unfortunately is a synchronous system. So it can only allow a single set of actions to happen at any given point of time. So if I want to execute 1 + 1, instead of being able to execute that 11,000 times for all of the nodes in the network, 1 + 1 is going to be executed 11,000 times so that all of the nodes arrive at the same answer. So now instead of having a parallel processing system, I'm forced to have a single event that's processed by all of these nodes. So the other thing that was important was verified computing. Now I'll go into it a little bit later as well, but just a high level concept is this way that if I do 1 + 1 and I give you the output of 2, I can also give you a proof along with that. Now this is where zero knowledge proofs come in. That shows that the circuit's executed in that fashion so that I arrive at that state of 2. So now instead of you needing to run the processing of 1 + 1, I give you the state and I give you the output, and then you can apply that to your ledger yourself. So that's a secondary mechanism that allows for this parallel computing system. So the high-speed consensus along with the parallel computing starts giving a lot more power on unlocking the design patterns in terms that we see in DLTs. And I apologize, Phantom is a research and technology organization, so we are very research and technology focused. So this is going to be boring for some, so I'll preface that, but what it comes down to. Okay, so very quickly, like I mentioned, the high scalability consensus, which is unlocked via the DAG and the parallel consensus. We've got the VM, which is verified computing and formal verification. It's a proof of stake system. Unfortunately, some of our marketing guys asked me to put this in. 3 million bonded stake, 15% annualized returns. I don't think that stuff matters, so let's move on. Yearly returns on the stake. I'm just going to skip that as well. Okay. So, I'm sorry, guys. I know it's important, but it doesn't actually affect the system in any way. Whether it's bonded stake or whether it's just voting by weight, it's the same outcome. It's just game theory mechanics, which is different to the technology itself. Quick demo, I'll try and do this as quickly as possible. We have a testnet up and running. It's anywhere between 21 and 25 nodes. We stole some of Netflix's Chaos Monkey technology. So at any given time, it tries to randomly crash nodes to create a very malicious environment so that there's disconnectivity between the clusters, there's network latency, there's all of these things. Now, this is only a 21 cluster node. So, I mean, that is tiny in comparison to blockchains. A blockchain that's truly decentralized, you'd be looking at 1,000, 7,000, 11,000 nodes. So I'll explain later why the results I'm going to show now will be a little bit slower eventually, but still, I'll go into it now. So a base part of the ecosystem is that it is a payment protocol, even though that payment protocols aren't necessarily important. I should take that back. They're very important. They're just not necessarily important now at this technology stage. So I've got my phone connected here. And I apologize, but I'm going to have to put down the mic for a bit. First things first, just to prove that this is the live connection. Let me swap that around. Hello, audience. Okay, this is my phone. It is showing there? Okay, cool. Thanks, man. I'll try and do this as quick as possible. So we go to the Phantom application. This is currently connected to the testnet. So I will do a quick shop. Let's grab a Google hoodie. Add to checkout. Okay, so we want to transfer funds. Scan the QR code. We need to pay 20, what's that? 22.15, 22.16, send, confirm. Me receiving this successful transaction, that's not submission, that's actually finality. To show that, let me actually just do a new version here, because I was playing around with this earlier. So shop now, let's grab this one now, add to cart, check out. 45, so, well, I'll show you on the screen just now. Let me just do this one again quick. 45.65, 45.65, send, confirm. Okay, so there we go. So that was a little bit of a lag because there's a push notification system behind it. But that, if we go to the logs quick, so this is just a single machine that I've got filtering our logs. So here was the submission of the original request, and here was the confirmation request. Now this is not like a blockchain solution in that if you look at something like Bitcoin or Ethereum, we have the longest chain rule. So what this means is that we don't actually ever have true finality. You assume after 3 blocks, the Bitcoin blockchain isn't going to be rewritten anymore, so it's safe to use. But a longer chain could come along and actually wipe that out. So if there's been a secret underground lab mining Bitcoin since day one and they have better processing power, then they could have a longer chain that they could replace the entire Bitcoin chain with today and then wipe out every single transaction that has ever happened. So there's never true finality. In BFT solutions, you do have true finality. So quickly, BFT, standard Byzantine fault tolerance. So that is where I ask everyone in this audience, do you agree that it says demo there on top? I collect the votes of everyone, and then when the majority have agreed, it says demo on top, we have finalization, because we all agreed on that. It can't change anymore because the vote occurred. That's standard BFT. Asynchronous BFT is this concept of not needing to have interaction with everyone at the same time. Okay, this is for the marketing guys again, some new partnerships, our network. This is a new ZAR-backed stablecoin in Africa that's building on top of the platform. This is a new insurance and banking system that's building on top of the platform. More details on that from the marketing people. I'm skipping along. Directed acyclic graph. Okay, so what does it allow? Parallel processing. How do we conflict resolution and time ordering? So anyone that sees this, you'll say it's a blockchain, right? Normal blockchain, block after one that looks at a hash. This is where I argue, look, this is actually a DAG, and it is of the category blockchain. So what's a DAG? A DAG looks more like this. So you have neat, ordered, one at a time, synchronous events, multiple parallel events. So how does this work? Quickly going through this. Genesis, everyone has the same Genesis block, and then any node at any given time can propose a new block. So node A that sits here proposes this block. Now in a BFT solution, it would broadcast this out to all other nodes. It would collect the votes. It would then again share the final results, and then everyone would decide on this. Asynchronous BFT is this concept that at any given point in time, I'm A, not going to know all of the participants, and B, can't at the same time interact with all of the participants. So what it does is it does bonded stake voting. So by virtue of when C here proposed a block, it referenced this block. So by referencing this block, it's giving its implicit vote to this block and saying, I'm also happy with this block. So now you have these two that have it. This block, by building on top of this one that built on top of this one, is agreeing with both this block and this block. So as gossip propagates through the network and this block gets shared faster and faster and faster, and other blocks are building on top of it, you end up having this fake vote that is about the fact that I'm bonding to a previous one by reference. So when this block is created, you don't have finality. Once it's been shared through the network to a point where more than 2n/3 of the participants are aware of the blocks, then you have something close to finality. In fact, you do. The real finality only happens another round after that, because you have this concept of known about known. So you want to not just know that 2n/3 of the network know about this block, but you want to know that they also know that it is known. It's a convoluted concept, but it works quite well in math. Okay, how many tech people do we have? Raise of hands. I just want to see how excessively technical. Okay, we have a fair amount, so I'll go into this. So an important part of this is what happens if there's a double spend year on year, and how do you resolve that? Because which one happened first? Because that's what a consensus is at the end of the day. It's an ordering mechanism. It's a way to assign when what happened without trusting logical clocks, because a clock can easily be manipulated in a decentralized or a distributed environment. So Lamport, and this is very old research, Lamport was one of the forefathers on almost all things distributed systems related. So we had this concept of a logical time. So Genesis is 1 and everything starts with 1. And if I create a new block and it references 1, then I increment the count. Now it's simply 2. So if you do that a few times, this block references 2, so it becomes 3. It references a 3, a 2, and a 4, so it becomes 5, and you just increment that amount the whole time. Now, this is the first and easiest way to order, because now you know 1 happened before 2, happened before 3, happened before 4, happened before 5. But now you still have this problem that what about the conflict that occurred in 3 and 3 here, in B3, which is the B node that produced it, and D3, which is the D node that produced it. So the next thing you extrapolate out of this is how much of the network knows about an event, because that references how long of a time it's spent in this network. So looking at this picture and assuming that this was time flow, which is not, by the way, you'd assume B3 was first. But if you look at B3, no one yet knows about B3. No one else has bonded on top of it. So B3 has not spent a lot of time in the network, versus D3 already has a 5 and a 4 Lamport bonded to it. So it has spent more time propagating through the network, which means it's also younger than the B3. So you have this concept of the amount of bond and stake you have on top of a node is its time ordering in the sequence. The very last one is if the bond is also the same, but then practically it happened at the same time, and then you just use whatever unbiased algorithm you have for ordering. In our case, it's just a standard hash comparison mechanism. A little bit more on how the groupings happen. I don't know if we need to go into this. For the more technical people, feel free to maybe ask me some questions afterwards. Otherwise, I'll just go through this fairly quickly. I want to be aware of my time schedule. The one thing I do want to mention is on block propagation. I mean, when I showed the demo earlier, you guys saw that it happened very fast. It's about 700 milliseconds for validation. And that has a lot to do with the network graph itself. So So the lines quickly, this is to inform 25% of node, 50% of node, and 75% of nodes. And this is in a 13,000 node network. So the bigger you increase block size, obviously the longer propagation takes. And you can see here for the amount you need to inform the network, it takes longer and longer. So at a 350 kilobyte block size, it takes around 35 to 45 seconds to inform 75% of the network. So you start losing that finality, not losing it, but it starts getting slower and slower and slower. And here's where this concept comes in about concurrent throughput. I hate talking about TPS, but it is technically the correct metric. So let's say I had one node and all transactions always originated from that node. And there was 10,000 other nodes that had to tell about it. So that would be a slow process because it can't leverage the ability it has on gossip or propagation because it's only originating from one node. Versus if it originated from all nodes equally, then each one is adding to the throughput and decreasing the latency. So the reason I mention this is just, you know, even these numbers that people throw around, million TPS, 10 million TPS, 100 million TPS, which by the way is all utter garbage. And please ask me about it in the Q&A so I can really tell you what I think about it. Is that each one of these solutions has a very specific niche for where it fits. And I think that's one of the nice things that Dan also said earlier is a lot of the times people think there's going to be one solution that's going to fit all. And in this space, it's simply not the case. Each one of these constructs is being built for a very specific niche that work in a very specific environment. This is very fast in localized distributed computing where the network graph is somewhere that's concurrent to each participant, but it is not good in a single originating environment where everyone else is simply in the ecosystem to try and leech off of processing power or whatever else it may be. And that's true for most of the solid projects and most of the guys presenting tonight as well. And that leads into something that's closer to a decentralized protocol. So Phantom has this fantastic consensus mechanism, and they're working on a very good VM. But that doesn't necessarily mean that they should be a full blockchain solution. In fact, they're closer to something like consensus as a service or distributed computing as a service. And the reason I say this is because you're gonna have all of these separate but niche specific blockchains eventually. And for them to really facilitate, they need to communicate. Now we hear the word interchain or interoperability or inter blah 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 a lot, and that's maybe on a protocol layer, not necessarily on a infrastructure layer, but it starts becoming important. And I want to hijack this a little bit. I apologize, Dan. In that for this specific example, let's quickly talk about something like distributed custodianship. So if you want to talk about a real DEX, a real decentralized exchange, you need to be the proprietor of your funds. So you need to have your own custodianship, and you need high throughput. These are the two systems you're going to have to need, and you're going to need to be able to map assets in some way, but that you can do via smart contracts. So if we look at IDEX today, and we look at if they trade a BTC pair, that's not actually BTC that they're using that's existing on the Bitcoin network. That's a custodian that holds the Bitcoin and then issues wrapped B2C onto the Ethereum network, and then that trades in IDEX. So it seems decentralized because I'm the owner of the wrapped B2C, which technically is an IOTA for the original B2C, but you don't actually have ownership of your funds. And most of the DEXs that are out today all suffer from the same problem. They have some kind of custodian that holds the fund. You hold the IOU, and then that's supposed to be distributed custodianship. So that's an example of something you need with a DEX, but that's not necessarily something Phantom's very good at. Like, that's not where we've done a lot of research. That's not what we've built, and that's not what we're focusing on. You need native on-chain asset matching, and for that, you're going to need a fast consensus layer. That is something that Phantom is very good on, so they can provide that to that ecosystem. And then you need to get to ecosystem agnostic, where all of these chains can work together. But an example of that, and I want to start leveraging this challenge to the community, because I'm getting a little bit annoyed at the amount of technical resources that gets wasted by each project. I mean, how many how many development hours have gone into building block explorers for each one of these chains? How many development hours have gone into building wallets for each of these chains? Versus we could have had one block explorer that facilitates all of them and have the best of the resources working on that. You've got all of these projects that have this very specific niche that they are very good at, that they have strong resources, strong technical development research. It doesn't really matter what it is. And they're leveraging it, but it's it's not being shared. We keep talking about open source and open community and working together, but each one is on their own race to be the first chain that's used by everyone. So we're trying to move towards a space where, you know, Phantom has got this fantastic consensus in VM, and IOTA is fantastic at IoT devices and being able to leverage that in real time in a distributed network without necessarily all of that data going onto a DLT. So, you know, for the smart city projects that Phantom's literally currently involved in, it makes sense to instead use IOTA's tech underneath and leverage that into the ecosystem. Phantom focuses on the stuff it's good at. Once you need, you know, distributed clusters and you need things that don't need a necessary global state, I'd like to grab Holotech and plug that into the ecosystem and have people leverage that. For that same reason, why I mentioned the distributed custodianship is Fusion, who was another project that I work with closely. I've got this fantastic distributed key write system that allows distributed custodianship. And Charles and Brett and the guys, thank you for being here tonight. And they're here specifically because they're going to share that tech. And likewise, we're going to share our tech. And we're going to keep doing this until we have this infrastructure layer that actually facilitates all of these chains working together in some way, or ideally something that's an amalgamation of the best parts of all of these chains and actually having a new standard and a new product that's available, leveraging the best parts of each and not having the one focus on what it's good at and then being forced to develop the rest of the components just because they have to. So Charles, I don't actually know if you want to come up or say anything, or if I've pretty much covered most of our conversation, because that's my conversation actually to put a stop in it. Oh yeah. So no, after you.
First of all, thank you everyone for being here today and, you know, being here for all these projects. I think what Andre is trying to allude here is you've got so much intellectual capital and just so much capital in general that's going to all these different projects, and folks are trying to solve a lot of different problems. But one of the issues that you're running into is that a lot of these projects, you know, are thinking very much or structured in a way they almost look like this collection of intranets, right? If you think about how all these different protocols are set up, you don't really have interoperability that allows assets to flow freely from one to another. You don't really have this exchange of like information that can flow freely from one protocol to another. And I think the challenge I'd like to throw out to everyone here today and the blockchain community as a whole, and what we've been trying to talk about is there an opportunity, right? Is there today an opportunity for projects to start thinking more holistically, right? Because switching costs are very high. You know, I come from the world of finance, and you know, I used to work for, I helped start a bank consortium, right? Made up of the largest investment banks in the world. And you know, I can tell you that these banks, switching costs are high. For a lot of projects, enterprise projects, switching costs are high, right? So if you're going to go ask a corporation to go out and all of a sudden stake a node and participate in your chain, like you may have some challenges there. But if we can build tech, right, that is easy to use, easy to interchange with, right, exchange information, exchange values with, right, lowers barriers to entry and allows this sort of like, you know, I've heard this term Internet of Values thrown a lot. How many people have heard Internet of Values thrown around a lot, right? So you hear this term Internet of Values thrown around a lot, but practically it's actually really, really hard to do, right? So if there is an opportunity for folks to coalesce, right, and think about how we can leverage our core competencies in a synergistic way, it starts to become really, really interesting. So, you know, part of what I wanted to just stand up here tonight is not even talk about Fusion, because we're just one small tiny piece, right? One small cog in this whole thing. But like, how do we start thinking more holistically, right? So that this intranet, this collection of intranet, right? This loosely federated collection of intranets can start to really look like, you know, what this Internet of Values can potentially be. So apologize, I'm not nearly as technical as this gentleman here, but but I wanted to share that point across. So thanks for indulging me. And Andre, thanks for having me up here. I really appreciate it.
But so I just as a closing thought, you know, I want to usher that to everyone. Like Eric Holochain, let's talk. Like Kevin Iota, you know, let's see where we leverage each other. Let's see what's and let's actually commit to the full ecosystem we can build, and not just our projects. You know, I mean, if we're truly wanting to be decentralized, we should do that on an organizational level as well as a technology level, as well as everything. Thank you everyone for your time.
Hello. Oh, hang on. My little pocket booklet. All right, so hi. My name is Eric Baer, and I am here from Holochain. I am very non-technical, but I'm marginally conceptual and hopefully like a smidgen fun. So one thing I have a concern about is because I don't normally present in depth about Holochain, is that in a place in my presentation where I might have ignorance, that you would relate my ignorance or my misrepresentation of a piece that is technical, if you are more technical than me, to the project without going and doing your own research, because it has like 10 years of in-depth work on it and a large and constantly building code base. So if you get to a point where you're like, that sounds stupid, that's probably just me and not the project. Okay, cool. So I want to ask a couple questions. Raise your hand if you came here because you're interested in Holochain tonight. Like that was your primary motivation. Okay. And then raise your hand if you're familiar with Holochain. Actually, forget the hand raise. I want to do a little upgrade. This is, I know about Holochain very well. And this is, I know nothing of Holochain, but you still got to hold it head level so that everyone else can see. And so where are you on that spectrum? I know a lot about it. I know very little. Okay. So it's an appropriate conversation for tonight. Great, thank you. And then raise your hand if you're really technical. Hold them high if you can. Everyone else can look around so you can get a sense of yourselves and each other. Raise your hand if you're an entrepreneur. Okay, raise your hand if you're other, like me. All right, great. Got a handful of us. All right, cool. So let's get into Holochain. Does anyone have any questions that are really burning to have answered over the course of this that I can make sure I like hit before it ends? No? Really? Okay. All right, so Holochain is a new way of running truly peer-to-peer applications. Holochain applications run entirely on the devices that the users that are using themselves, right? So you can run a Holochain app eventually on your phone. Can't do it yet. And Holochain applications require no web servers, they require no mining, and they require no cryptocurrency. You can build those things on them. I don't know why you would want to build mining if you don't need it, but you could if you wanted to for fun. And this is really important. I want to emphasize the no cryptocurrency. It's an easy thing to get confused with because we have HOT, right? And we have Holochain. Those two things are separate. You can build another currency on top of Holochain if you want to. Okay, and we already have people that are doing that. Holochain is a framework, an open source framework for building dApps. So yeah, okay. So that you can offset your own use. The way it works is that you offset your own use of a Holochain app by storing, validating, and serving content on the network that app that you're playing with other people on with that app. Okay. So Holochain is a pattern and not a platform. Okay. That goes back to the framework thing. That's like the difference between JavaScript and what's the thing where you build the websites? You like plug the pieces of the websites in? What? No, like the Squarespace. That's a platform. Yeah. Or like, what's it called? Like blockchain is a platform, right? So there's no one big holochain. Like there's a big blockchain. There's no one big holochain. There are many holochains. And each app is its own separate social space. So on the Ethereum network, where anyone does something, Andre was making a point earlier about the hot token gets really busy, and that's going to clog up the other tokens because they're on the same network. It would not work that way on Holochain. A Holochain app would be each app is its own social space, its own community. Okay, so and in each social space, members play by a shared set of rules. That's the app. The app's DNA is what we call it. So we're solving for we have this structure because we're solving for a different problem than the problem that blockchain is solving. When the blockchain is trying to solve the problem for digital anonymous cash, okay, it came out of the cypherpunk community, right? And then Bitcoin came out of that. Okay, so we have a different goal. We're not looking to create digital anonymous cash for trustless interactions, right? We're trying to foster more effective, adaptable, and vibrant communities. It's much more ooey gooey, heart spacey. Being honest, yeah. So, but still pretty practical. So blockchain is focused on transcending relationships. Like, I don't need to know you, and you don't need to know me in order for us to have a transaction and for us to be totally safe. You know what I mean? And we can go our separate ways, and that was okay, right? But that's not going to like lead to any real development of any actual changes in the world or any changes in how we treat each other and changes how we treat money and finance. And it's not going to lead to the actual goals that are the premise for creating cryptocurrencies, right? It's not about being able to not know anything about each other so we can do a better job of buying porn and drugs. It's about like, how do we create stable systems for exchanging value so that we can create new ways to exchange value to change the way people relate to each other and change the way things work in the world for the better, right? So Holochain is focused on fostering relationships, okay? So we have a different goal, and a different goal means we have a different architecture. So to create a P2P application framework, we've combined tech from three established projects. This is an oversimplification. And those are tamper-resistant logs from blockchain, efficient shared storage from BitTorrent, and agent-centric identity from Git. Okay? So how a Holochain app works is a user installs the app on their device, all right? And then that app is composed of 4 different parts. Identical rules with every other device that's running that Holochain app. And if someone changes the rules on their app, they're no longer playing the same game. They are leaving that network. Okay? So by cheating in that way, you're quitting the game, right? Because I can see your rules and my rules, and I can compare them when you and I interact on this application. And then if we're playing by the same game, we know we're playing the same game. If we're not, then we're not playing. Okay? So your data is on your device, and it is backed up on others' devices. Okay, so identical rules means every user of an app plays by the exact same rules. I explained that already some. An example of this is Twitter with 140 character max tweet. So only users with an invite code. Oh, so this is, I'm supposed to go into more depth here because it has notes on my thingy. Oh, yeah, okay. So then you could set this up where anyone can join the app, and you could set it up where only users with an invite code can join the app. And this goes back to, say, if I have an invite code that's part of my rules like prove that I joined the app through an invite code, and you join the app without an invite code, and we tried playing with each other, my app would just reject it, right, outright. And if you had the invite code, then we could play together. So why identical rules is that this is more. Does everyone kind of get that well enough, or should I keep more explainy? Some responsiveness. Keep going. Keep going. Keep going. Okay. Okay. So that's a good example. Okay. So the rule enforcement in a card game. Let's say we're playing poker, and raise your hand if you've ever played poker. Okay. Raise your hand if you've ever played poker and someone cheated. Even playfully, it counts. Okay, more hands go up. When you're playing poker, everyone around the table knows the game that they're playing. Everyone knows the rules of poker. You're not like if you break the rules, then 2 things happen. Okay. Shit. This is like further back this way. Someone notifies others and they take action. So if you take a card when you're not supposed to take a card, it's not your turn. I'm going to say, "Ooh, what's your name?" Praveen. I'm going to say, "Praveen, you can't do that. Don't do that." I've done 2 things. I've called you out, right? I've taken an action, and I've notified others. Now, everyone else is going to be watching. If you're doing that again, maybe you did it by accident. Maybe you did it on purpose. If you do it again, then someone else is going to say, Don't do that. Yeah, like prevent, don't do that, right? So now you have the group is actually aware of it and taking action. So we call this an immune system response. And that's actually how immune systems work in our body. It's there's a cooler example that I like more, but that we don't use as much, with white blood cells, and how the body reacts when there's a problem is it takes care of the problem until the problem's not there anymore. And then it just doesn't deal with it anymore because it's not a problem anymore. So Holochain apps are designed, or Holochain is built so that you build apps with an immune system. And you think about creating security in your application and your network through whatever parameters you need in order for those interactions to be secure. So every action you take, so authorship is a really important point, is every action you take is cryptographically signed by your device. So it's, I am doing this every time you do something. And it's the same problem with anything where you deal with passwords and key management, is someone can pretend to be you, right? So we haven't like fully solved that problem. We're working on it, but it's another big problem. But it's a way to say, this is me and I'm playing this game. I'm gonna see if there's more stuff I should get into there. Yeah, it's just everyone has your private key, public key. And then it's how much work does my phone have to do to run an app, right? So like, let's bring it down and make it practical. Is this something that you could actually do? Like, you're not going to run like CryptoKitties like crashed real bad, like everything, right? So like, how scalable is this really? So we'll take the example of a peer-to-peer Twitter. 140 character tweets will be our limit for this example. And let's assume that our app is really, really ridiculously popular and 7.7 billion participants, every human being on the planet is tweeting, which would be just the saddest, not the saddest, but just like, oh man, we're so fucked if that's the case. And like, it's 1.1 tweets per day per person. And we're backing up each tweet that everyone tweets. 1.1 is the average number of tweets that a Twitterer tweets per day. I'm not on Twitter, by the way. And let's say we're backing it up 100 backups to the network, right? So every time someone tweets, that gets sharded out to our distributed hash table to the network just on that application, not on all of the Holochain applications, just for that application. And then everyone's doing their share of the workload, right? So that's 110 tweets that every day that someone's storing on their phone at 140 characters each. Okay, one tweet is about 568-bit bytes. Those bytes times the number of tweets in a day times the number of days in a year is like 22.5 million bytes per year. And that's a little less than a 24 megapixel phone. And that's, so like raise your hand if you would store 1 megapixel like picture on your phone to be able to operate on Twitter with like owning all of your own tweets and having access and not having it be like run by Twitter, right? So that's the accessibility piece of it. So for 1 year of use, that's one photo. Okay. And it's easy. This is like a light amount of work because you're only backing up 100 times. You're not backing up everyone on a blockchain. Everyone has to remember everything. It's just not the way reality works. So, yeah. Yeah, so this is just blah, blah, blah. It's really good, blah, blah, blah. And the caveat is tweets are small, right? P2P YouTube would need way more storage. But the example still stands as the P2P storage that you would have to do on a blockchain for something like YouTube is just impossible. Whereas here, it's just with Holochain, it would just be a matter of, do you have enough devices hooked up to that network that are storing and serving the data effectively? And if you do, then it works. So it becomes a possibility. So this efficiency is great, and this scalability is really fucking. I'm only gonna say it once each time. I'm gonna stop. The scalability is really cool. But the really exciting thing are the new capacities that Holochain creates. And one of the things that you can do with Holochain is you can remix several apps into one. We have a really loosely coupled user interface. So that means that the example would be putting ride sharing applications together. So let's say that there's a Lyft, an Uber, and then 2 different local co-ops that were built on Holochain for ride sharing in a city, right? And each one's got its own little quirks. And just like with Lyft and Uber, drivers drive for both, right? So now you could take a UI and you could bridge these apps together, build like a meta UI, and then what you would have is, as a user, you'd be able to take your phone out and request a ride, and then you would get these different options that would come to you. It would bridge them all in. You'd be able to select the one you want. It would cancel the other ones, and then you'd be able to choose which ride through which provider. And the drivers similarly would have their own version of that to be able to offer rides to these different applications, to these different communities. So what we're doing is we're putting humans at the center. We're not putting corporations or data at the center. We're putting the people at the center. And one of the important points about Holochain is that it's agent-centric. All of the information that comes out at any point is coming out from someone. This is the truth anywhere, period. Someone or something, right? It could be an IoT device asserting some truth. And the mistake is that we assume that we can make a global consensus, just like we assume that we can make a global consensus about reality, but we can't. Like every single human being lives in a different reality. And the thing is, we conform our realities to sync up with another's perception of what is and what isn't well enough that we can coordinate and communicate and play together, right? So Holochain is a technical infrastructure to facilitate apps to be built based on that kind of assumption. Does that make sense? Or does it just sound like blather? Where am I landing? This is like, I'm totally tracking you, dude. And this is, I'm politely waiting for the next person to go. This would be really great feedback for me. Totally, be honest. Okay. Some people are afraid to be honest. I just assume you're down here. So some use cases are peer-to-peer social media, disaster relief coordination, supply chain coordination, P2P currency systems, crowdfunding platforms. Is Junto here? Junto? How is it pronounced? Okay, I'm so sorry. Junto. Shout out to Junto. Thank you so much for coming. Building a crowdfunding platform, right? Oh, sorry. You.
Hi, Eric here. So we came across Holochain a little over a year ago and have been, moving into the space of decentralization. And Junto's a distributed social media, but it came from a deeper design philosophy of wanting to move beyond a lot of the restrictive social norms, addictive qualities, mental health concerns, privacy concerns. And so for us, we kind of take a more humanely designed approach in terms of like no advertisements, no vanity metrics, no AI. That kind of reinforces those existing beliefs. And we integrate it we build it on top of this distributed technology to provide people with ownership of their data. And it's not for profit as well. And we just actually hit our Kickstarter goal of 100 grand this morning. So it's exciting to be here. And thanks for the shout out. I wasn't expecting that.
And misidentifying your organization. All right, cool. So, and there's a handful of other really cool projects. Not a handful. There's more than a handful of other really cool projects building on Holochain right now. And then, okay, this is really important. How am I on time? Am I over? Too far over? 2 minutes. All right. I want to make a clear distinction what Holo is and what Holochain is. Okay. So Holo is a P2P web hosting marketplace. Amazon Web Service and Airbnb created a cool baby with a cool name, or maybe, called Holo, right? You're all supposed to be laughing at these jokes. And then, so Holo is a bridge to mainstream users for Holochain apps. You can build your app on Holochain, and I can only use that app if I'm running Holochain locally. But I want my mom, who is technologically severely illiterate, to be able to open up her browser and access Holochain apps. She doesn't need to know they're Holochain apps. They're just going to be running on Holochain on the back end, and she's going to have whatever normal user interface she's going to have, right? So, and this is also how you can get into serving more data than you could just deal with on your phone. This opens up the YouTube possibility. So Holo is that bridge to the mainstream. So Holo is the marketplace for that. So we did a Indiegogo campaign, and we raised a bunch of money, and we're making these cool hosting boxes that you can plug in, and they run Holo so that you can then provide service to this network. And then we have these all over the world, and eventually everyone will be able to just like download holochain on your computer, and you'll be able to like run holo on that and then provide service to this network, so that we have like a true cloud hosting, like what's the word, like network around the world. And this solves two problems. So removes the barrier to mainstream use, and it subsidizes holochain. We are not getting paid for making holochain. It is an open source project. Holo is just an app basically on holochain, and you don't need holo in order to build an app on holochain by any means. You just need it to bring it to the world on their browsers, web browsers. You can learn more at developer.holochain.org. That's the end of the slideshow. That's the display and color options on my computer. Thank you.
Just pulling up the slides. Next up is going to be Kevin Chen. There we go. Kevin, I'll let him present himself, but he's part of the IOTA Evangelist Network, and he's going to be presenting IOTA.
Cool. Yeah, looks like I'm a malicious actor for the No Shoes Network. Hopefully the network is BFT. 2/3. Cool. Yeah. Hey, everyone. So my name is Kevin Chen, and I'm the founder of IOTA Evangelist Network, and I'm also a co-organizer with Dan for the IOTA meetup group here in New York. So just a quick show of hands. Who has been to an IOTA meetup before? Wow, less than half. So we have a lot of new people here. So who's vaguely familiar with IOTA? All right. So yeah, yeah, some familiarity, but yeah. So for this presentation, I'll definitely go a little bit also to the basics as well. And just a quick description of myself. I created the IOTA Evangelist Network, and this network is a group of dedicated IOTA enthusiasts, developers, and professionals around the world who's looking to evangelize, trying to spread the awareness and adoption of IOTA technology around the world. So yeah, without further ado, let's begin. This way? I was holding it the wrong way, so it's pressing the wrong arrow. Yeah, so yeah, for the structure of this presentation, I want to discuss a little bit about the two parts. The first one is kind of giving an overview of what IOTA is, a little bit of like how it works. But I also wanted to emphasize a little bit about the second part, about the need of developing a global ecosystem. And this is kind of something that's kind of discussed with Andre, of actually trying to build more of interoperable like technology infrastructure. But I also wanted to discuss that there is also a need to develop interoperable and co-create new different types of ecosystem where you can have different businesses, no matter which type of domain industry that they're in, to actually work together and to share data with each other, and actually try to find ways to actually break down the barriers of actually trying to hide like the data, and actually have them to kind of have the incentives for them to share data rather than for them to hold it, and use that as the way for them to have value. So a quick overview for IOTA is that IOTA is a DLT for the Internet of Everything, and has some features that includes scalability, low fees, quantum resistance, and some of which that I'll get into here. But before I get more into like why IOTA and how it works, I kind of wanted to go and also give a little bit of a background as well. So data is the new oil. So that means that data, especially valuable data, will become valuable assets for business-driven purposes. and ultimately with the hopes that these data could become standardized, then they can also become commoditized as well, just like how oil it is today. So what's driving this data is a new oil trend. And then there's 2 or 3 different factors. So the first one is that there used to be data silos where all the different like businesses are just kind of hoarding all the different data in their like on-prem data centers, and then they're just using the data for themselves, even whether they actually use the data or not, but they're just like holding onto it. And then there's a more recent development, which is called the cloud, where now there's data is becoming more like open, and it's become more co-located into different cloud providers such as Amazon, Google, Azure, and others. But nevertheless, that there is still owned by like private entities. But I think the big transformation, and the one I'm most excited about, is the rise of Internet of Things. So who here is familiar with IoT? Cool. So yeah, so IoT is more of like an internet of, so like today's internet is just like internet of computers, mobile phones, servers, data centers, etc. But I think that tomorrow's IoT has a more diversity of different types of things, widgets, gadgets, appliances, devices, machines that could then become connected and onto the internet today. And I think the part that really excites me the most about the IoT is how like you have all these different devices and sensors are able to gather all these different types of physical phenomenon around this world, and you will have the understanding and the awareness of all the like the phenomenon that's going on. And I think this could really help us like understand, like if we have less blind spots of the different things that's going on around the world, I think, and we have this information, I think that this can really help us make a lot better decisions. But we're still not quite at that utopia, so to say, because there are still some kind of obstacles that are preventing IoT from becoming completely ubiquitous. And one of the big ones is that there's still a lack of trust in the, okay. So there's still kind of a lack of trust in the data, especially about how the data is being originated, whether like the data is actually coming from the sources that you think it's supposed to be coming from, or could it become like be from an imposter, that someone is like faking the ID of a certain device and is giving you bad or faulty data. The second one is still a lot of the network connectivities, which is still need for real-time transactions. And there's also some kind of interesting developments, including the rise of like 5G networks, where they are the throughput has been increasing from 4G is kind of like 100 megabits per second to 1 gigabits, and then 5Gs will be at least 10 times faster than that. And then the third one is, oops, spoilers. Yeah, and then third one is like how to actually develop business models around like trust in data and actually the connectivity. And that includes having more smarter, more intelligent business models, as well as increasing use of automation. And I think one of the big values of automation is that even though that there's a rise of big data, of course, it will not be possible for like just humans to consume all that data, since right now we're already overloaded with the data coming from like the internet, from the web and so forth. And then we'll get even more overwhelmed if we're trying to ingest like raw data from like devices themselves. So there would be a value for automations and robots to kind of pre-process this information, and then to kind of curate this data, and then to make it more digestible for ultimately for the human users to view, and with the hopes that they can make better decisions. So how does blockchain come into play here? So blockchain may really help with the trust in the data by using the primary example of blockchain, which is a cryptocurrency. You need to use the private keys in order to like create a digital signature and then sign and make it put into transaction. And then you have like other parties, like in Bitcoin's case, like the miners, who then would have to like authenticate you, like making sure that your digital signature is real. And then before they actually put your transaction to the block, and then it goes through the proof of work process, and then actually getting that block actual validated, confirmed onto the blockchain, hence your own transaction. So it's possible that we can do similar things with, instead of using Bitcoins or cryptocurrencies, that you can actually use like IDs of different things or identities, and then use the like the cryptographic schemas that's already been built on Bitcoin blockchain to do the same type of authentication. However, and also the reason why we're currently here is that there's also some challenges in the blockchain space, and then primarily with the issues of like the scalability problem and the high fees, because Bitcoin right now is kind of built to be kind of fixed at a certain block interval, like a block interval size, which is about 10, 15 minutes per block, and it can only fit about 1 megabytes of transactions onto it. So on average, it's only able to process or confirm 3 to 7 transactions per second right now. And then this makes it, there's a high variability of the like the fees that's associated with Bitcoin, for example. And then that's mainly because that you cannot like really like make the block bigger unless if you like fork it and then try to make it block bigger, which is what actually happened a few times. And because of that, if there's more demand for this like fixed supply of block space, like the space where you can put the transactions, then of course the miners will then have to charge like higher transaction fees, and they will of course pick the transactions to put into their blocks that gives them the highest amount of fees, because miners are incentivized by financial returns for their like electricity and energy for them to actually run the miners in the first place. So this is where this is where there's this rise of these new distinctions as addressed by the two previous speakers. There's a rise of a new type of like categories of blockchains, which is called DAGs, directed acyclic graph, and IOTA is one of them as well. And the key feature of DAGs is that they want to resolve these scalability issues that's been plaguing blockchain, so that especially in IOTA's circumstance, that is able to make distributed ledger technology to be more accessible to use cases such as IoT. So just a little bit of quick run through of how the IOTA transaction works. It's like a specific type of DAG where there's, so you have these, so these are first actually transactions. There's no blocks in IOTA. So these are individual transactions. And so these are confirmed transactions right here. These are unconfirmed transactions, but they're still on they're recently attached onto the Tango. So just a real quick difference. The Tango is the name of the DLT, and IOTA is the name of the like the organization of IOTA as well as the token. So there's that small distinction. So how the DAG works here is that so let's say that we have like a new incoming transactions. I made a transactions to, let's say you, Brad. So let's say that this is this transaction right here. So in the protocol, whenever I make a previous transaction, the transaction actually validates 2 previous transactions right here. And then the validation process includes things like checking to make sure that the digital signature of the transaction works. Also make sure that it's not a double spend by transversing through the Tango. And then the last part is also a proof of work, but this proof of work is actually not part of the consensus. Rather, it's part of a way to prevent too much spam. It's kind of like the something called a hash cache, which is like a proof of work where when I send like a email to you, that the server has to do a little bit of proof of work to get it through to my receiver. And this is a way to prevent spams from sending like thousands of transactions to a given inbox, and then like trying to spam the like that inbox, and it makes it harder because for each of these emails you have to do a little bit of work. And so this is kind of the same thing here on the Tango as well. So after each transaction goes through like all three of those steps, then this becomes like a purple and becomes an unconfirmed transaction. So how does it get confirmed? So how it gets confirmed is until enough future transactions directly or indirectly validate our transaction right there. And if it passes this certain threshold, then this will be marked as confirmed. And how does this, and then who sets this thresholds? I think long term, it will ultimately be decided by the users and the receivers themselves, that they can determine based on how important this transaction is, how much future transaction will have to validate the like directly or indirectly their transaction. Although I think in the future there might be some kind of standards of what type of like the number or the weights of the transactions that's needed. So this is just like a quick like a graph about how the Tango works. And I mean, there's a lot more details to this, but I think this is a good enough like overview to just kind of explain how it works. And one of the big key here is that you see in this validation consensus process, it's driven by all the transactors. So transactors validates previous transactions, and then future transactions validate that transaction. So what this means is that there's only one user group in IOTA, and there's no minors. And because the minors are not needed, because the validation process is inherent to the transaction process itself. So, so one of the big benefits here is because since there's no minors, there's no need for mining fees. And hence there's no fees on the IOTA transaction. And this makes it very, very useful for doing things like doing microtransactions, or even doing batches of data transactions as well, because you can send a bunch of mini transactions without having to worry about having to pay underlying fees in the protocol. And this is one of the key features of what makes IOTA pretty relevant to IoT, is because of the likelihood of all these different types of devices are able to do like microservices or resource sharings that might involve like nano transactions with their counterparties. So there's a lot of different opportunities here. How am I doing on time? 5 more minutes. Okay, so I'll just run through some of these use cases, since there's actually a lot. But I think one of the big themes is that even though that IOTA, DLT, and even IoT, they are like horizontal technologies or general purpose technologies. In short, is that they can transcend various different types of domains. Domains includes like mobility, smart cities, supply chain, manufacturing, and so forth. And I think in the future, I think we'll see a lot of these different like domains actually kind of blurring with each other, and it's kind of hard to actually kind of categorize these different like domains like distinctly, because these technologies kind of traverse through each other. There's a lot of kind of co-creation, interoperability that's going on with these types of domains, and that might be kind of an interesting node, especially like in the those in the financial industry that are like for example like investment banking, that they have like cover like specific like industry groups like industrials or healthcare or FIG, that there might be a likelihood that they may need to interact more with their other industry groups as well, or maybe even combine to join new ones, and so forth. So one of the big ones, I'll just go through real quickly, is the rise of applications in the connected vehicle space. So the connected autonomous vehicles, and that could be the one of the most interesting, sophisticated, complex IoT device that's out there. You can say because in order for it to drive autonomously and carrying passengers while minimizing any risk of like accidents, you need to have very sophisticated types of devices, sensors, lidars, and then maybe even more types of intelligence and also connectivity to the environment, smart cities, in order to make sure that like the passenger, the client, not only is absolutely safe in all circumstances, but it's also having this very enjoyable experience as well. So one of the potential use cases is that connected vehicles will also become very digitalized, and there will be some kind of a digital representation of these vehicles called digital twins. And the digital twins is just like what the vehicle is, what it does, but more represented in digital form. So some of the examples could be like having this car ID itself, like a VIN number, but it can also be different specific IDs as well. For example, like the different parts, like they can all have IDs. And what's useful is that I can go to this one, which is a use case, which is a UBI, which is usage-based insurance, is that instead, like for example, currently car insurance is based on for different people. And so each one of us have car insurance. So if, for example, if I drive really poorly, then my rates will go up. But let's say that in the future that you have more of these autonomous vehicles that basically drives by themselves. So there's right now an exploration of a new types of insurance paradigm that instead of the insurance being mapped to like individual people, that these insurance could be mapped onto specific cars themselves. And how would insurance company kind of determine what's the premium for, like if they're basing it on a specific vehicle, instead of getting like human information like social security, age, like your grade of your report card, you can get something like all the information from the car, and that includes odometer readings, telematics, when it went to the maintenance, how many passengers it drives, and all of this information comes from the cars themselves, and in order for the insurance companies to actually like understands or is comfortable with the information it's getting that's actually coming from this actual car and not from like an imposter, that's where like a DLT would really come into play because of the authenticity and the identity of putting the different like the vehicle ID itself or the vehicle parts, and then create a digital signature, given that this vehicle has its own private ID, private key that it keeps, and then creates a digital signature, and then the insurance companies could then validate it and then ensure that these streams of data, telematics data, is actually coming from the car itself. So let me see. Another useful, interesting use cases are more of like smart cities, where right now some of the recent developments is that IOTA is doing a, just like real quick marketing. IOTA is doing, just working with the city of Taipei, Taiwan, as a way to create a more of a citizen-centric ID. So this is more of a like an identity of human users here. And but another use case that IOTA is also doing is the creation of a data marketplace where you have all these different devices, and so they're like data originators, and they get these different data, and then they can actually have these marketplaces to sell these data to third-party potential buyers. So in the previous, for the previous use case with the UBI, so you have two parties, the cars and the insurance companies themselves. But then the cars could then sell these data to the data marketplace to users, to buyers that think that these type of telematics data might be useful. And one of the information could be like the actual like the smart cities themselves, since so maybe some of the sensors that the car could collect are for like road conditions, since these cars have like cameras right here, and then these cars that can then collect these like images or even videos and then send it to the smart cities, and then the cities can then determine which roads that they need to fix, or which road needs better maintenance by the data that they've collected. So that is a really major use case that IOTA is doing. And recently, today, they've actually announced it to be open source. And right now, they've partnered up with all these different participants, these organizations, to be part of the marketplace during the trial. But right now, they've also now released the code, so anyone could produce that has like sensors could then plug into the marketplace, and then maybe find and be part of the data exchange. Even though right now it's a proof of concept, but hopefully that this could be used in more commercial purposes down the road. So so just finally, IOTA is run by IOTA Foundation, and is a group of it's based in Berlin, Germany, and has a team of at least 90 people around the world, and they're all actively trying to develop, continue to do R&D of this technology, but also trying to educate and also research and to standardize this technology as well in order to reach the next level of adoption. Yeah. So here's my information. Here's my details, and here's more information about IOTA. Thanks.
All right, so now probably the most exciting time. We're gonna do the Q&A. So do you guys want to come up here? That'd be cool. Yeah, you want to come up? Let's see. Actually, I'll put on. Put your thing back on. I can say that.
You want my computer back?
Yeah. All right. So who wants to kick it off? We'll keep it really fluid. So anyone wants to ask any questions? We'll go around. I'm sure we got a bunch.
I actually have several questions on the problem. I'll wait until.
You want to make sure to speak in the mic.
Okay. For your last slide, you had universities mentioned. What are you doing for universities?
Let's see. So I think so like the universities we've done currently and or like in the past include like UCL. We did a stint at Berkeley. Let me see. There's one in like Norway. It's called NTNU. I think there's also a university in Russia as well. That I don't know whether we're still. I don't know. Well, first, as a disclosure, I'm not involved with the IOTA Foundation anymore. I'm working as an evangelist, and that's kind of like separate from the foundation. But I think that the foundation is also working with a university in Russia, and they're working on some kind of simulation of how the Tango may work while it's at scale.
So, like what Andre was saying earlier is that like blockchain's a like one size fits all solution, and in Holochain we have a one size fits all solution doesn't fit all. So for Holochain we have a fit for purpose solution, right? Andre's probably better equipped to communicate about the Sybil attacks than me, but I can touch on a couple pieces about security on Holochain. Is that if we high five, right? Do you care if everyone remembers that? Oh, that was awesome. All right, let's high five. Do you care if everyone, do you want everyone to remember that first high five that sucked? I don't. Okay, whatever. So we don't need any security for that high five, right? Like I don't need a huge amount of security for that high five. I want to text my girlfriend a heart emoji, right? I don't need a high amount of security, but if I want to approve of that text, but if I want to approve of a nuclear missile getting sent out, and it's still a sending action, right? I want a much higher level of security. So on a holochain app, you set the parameters for security for the needs of that application. The same way as you set the parameters for the storage or for the backing up, right? So I might need to know, like if I'm going to have an interaction with you and I'm going to sell you a house, we're going to want a ton of people making sure that my identity that I'm representing in that purchase and your identity and your assets and my assets are valid. But what we're going to need for the instance of a house is going to be different from the instance of a high five or a heart emoji or a nuclear missile. You want to explain Sybil attacks?
On the Sybil side, again, Holo allows you to have a fully configurable system. So you could, because Holochain just powers the app itself. So nothing stops you from implementing your own proof of stake system in that to convert Sybil, or you can have a proof of work entry mechanism to stop it. I mean, you'll have a very specific defense for a specific attack vector you expect in your solution, but it's not generalized to all of them because not all of them need it. So the tools to facilitate a defense, if you expect yourself to be susceptible to that, you can build within the architecture. So in the example of the house, there you have a bunch of participants, so you don't necessarily then want to be able to get a Sybil attack there by someone. He decides he's going to throw 51% of the participants and then obviously claim it. So, okay, never mind.
So you don't need to do proof of work, period. Right. So because we have, and you can correct me if I'm wrong, because we have a distributed hash table, right? So like, let's say we're all on one app right now, and when it's on the Evan and Bear house buying app. That's the name of the app. You can find it on Google Play right now. Thanks, Evan. That we're on this app. We're all on this app, and that we require 20 people to let's say everyone in New York is on this app. It's a very popular app. When we're pulling to validate that interaction and to prove that we are who we are, we're pulling at random. You can't actually control who's on the network unless if you have a network of 5 people, yeah, you can have all bad actors. But if, let's say you have all of New York City and you've got like 40,000 people in New York City on like helping you, you're still not going to be able to do it. And if anyone is putting information out that's saying that what that's validating your change of state, because you have a local state and I have a local state, you changed your local state to lie about how much money you have, I'm going to pull from that network. And if one thing from that network shows up and says it doesn't match, that's going to be a buzzer to me to check into it more. So that's how we do it, I think. I know you don't need to do proof of work to avoid Sybil attacks.
Must the Holochain applications run on Holo, or can they run on any cloud infrastructure?
So if you want your Holochain application to be accessible to anyone on a web browser, you use Holo to do that, to do that serving. But you can also create your own network and serve it from your own network, theoretically. I think that's actually what hum.earth is doing right now, and they have a Holochain application that's live, and Holo is not, right? But effectively, easily, and scalably, if you want to serve something to the world, Holo is what you do that with. But you can run your own Holo. Hell no. No. Holochain is a framework. You can, yeah, okay. I get loud because I get excited.
I think this question is for Andre specifically. I think you had it in your slide on how you're, like in a smart contract world, how you're preventing us from having to execute the same smart contract on every single block to validate that, that piece of code actually ran. And I think there's something around the whole zero knowledge proof or something, but I'm really curious, like how the hell that works. Like, how do I know that it was that contract that generated those transactions and not an imposter contract?
Yeah, so what you do is a traditional VM just encapsulates the VM itself. So you wrap, now that VM execution is just a set of circuits, and these are standard arithmetic circuits, logic AND gate or OR gate or whatever you might have in there. Now, what zero knowledge proofs, specifically Snarks and Starks, allow you to do is they allow you to codify these circuits in a set of rule that then map out the sequence. So what zero knowledge proofs do is they sample, and this is not a technical explanation, I'm trying to bring it a little bit down. They sample one of these circuit areas to see what was the result of the answer at that point in time for the execution, and then test that against what they expect the full execution to be. And that allows them to generate a proof system. So the arithmetic itself of the logic gates is what creates the proof system that at any given point of time that can't be known by the generator or the attacker is generated to prove that it did reach that logic gate successfully. So by doing that, the output that you have that gets generated along with the execution is the proof. You can bring it back to standard public-private key signing, in that by signing this message and giving you the public key and the message, you know that I'm the owner of that private key. It's a similar concept, but with code execution. So by having the output, having the proof at the given point of the logic gates, and having the inputs, I can, with just these 3 bits of information, test it like a private public key pair and know that the execution, as if the execution is the private key, occurred to sign the output of the message. And then I can just apply the state differential there. So you would output a standard Merkle tree, for argument's sake, and then apply that to your own state system. So in complex logic, it's faster. But for example, if you did something very basic like 1 + 1, it's actually more effort to test the proof than it is to test the execution. But in complex execution, it's a lot faster to test the proof than to actually do the execution.
And you're validating that the code executed did what it did? Can you also validate it that it didn't do something you didn't want it to do?
So technically, you can only test that it does what it's supposed to do.
So you can test the fact that the outputs are correct based on the inputs. But if I've got like I can't prevent somebody who, say, maybe creating a secret log inside that contract, like it wouldn't necessarily like validate that, right?
So when the circuit is compiled, it's compiled off of the binaries themselves.
Right.
So you won't really be able to inject that, because any change in the bytecode output affects the circuit output.
Okay.
So, but let's say you had it one level removed where you weren't running it on the bytecode, but you were actually running it on this execution and not testing the bytecode, then potentially you can do something like that. But because it's part of the precompiled binaries of the bytecode, no, you won't be able to inject that.
So you basically do get some validation that like this piece of code, when it ran, really did come from like this GitHub repo, like it was this version of the contract.
So it's that signed binary that's available and that runs, and you can always test that against the original execution as well.
So it's validating not only what you wanted it to do, but you also get some validation that it's not doing something else that you don't want it to do.
Yeah, so that's actually where, so verified computing is the one part, which is specifically the output of the circuit, but the other side is the formal verification that I mentioned earlier. Now the formal, because when you see GitHub code, you still don't necessarily know that that code is the binary you're running. So the verified computing is the binary that runs and proves that those inputs created those output. The verified computing is the thing that actually says this source code based on this hash created this binary, and here is a certificate certifying that it is the output thereof.
Yeah,
so
that I can get the understanding of how you could do that. You could generate a trust chain from the source to the compiler to the binary.
Oh, you shouldn't.
Well, yeah, I mean, I know, yeah, in general you don't, but I can imagine, I can see how you could build that. You know, you could build a signature.
So one flaw of this is that because you have to use you don't have the full elliptic curve math at your disposal. So your circuits are a little bit limited. So you don't have full like Turing complete systems technically. You can build it with the correct amount of logic in it, but it's more effort for the user. So it is a very specific kind of execution contract you're talking about. But it's perfect for standard financial contracts and these kinds of things. It's not really that good for super complex contracts because you have to use the pairing-based cryptography instead of elliptic curve-based cryptography, but that's really the only shortcoming thereof at the end of the day. And then you've got a proof system for execution. So it's not actually just that we're using. There's actually a secondary mechanism because now each of the nodes still have to validate that proof output, and that's still a lot of overhead. So that same knowledge graph concept we have in our consensus, where the one tells the other one that it told the other one, which creates that graph, we actually do the same with the proof system as well. So if there's 3 nodes The first one tested the proof, the second one tested the proof, and the third one knows that the second and the first one tested the proof, then it doesn't test the proof, it just applies the state, which also cuts that overhead a little bit more. But that's actually a secondary system to the knowledge proof. But there's a lot of really exciting stuff happening in the zero knowledge space. Bulletproofs are great for long range attacks. Snarks are fantastic, and we are using them. The problem with snarks is they require trusted setup, which currently obviously isn't great in the distributed environment. And the research happening on Starks right now is with a completely trusted setup, and it's linear testing on code execution, so it's not as fast as snarks, but it's better for a decentralized world. So if you're interested in the space, definitely go check out those three. They're the three front runners for this technology. Awesome question, by the way.
We're just gonna take one quick question from. So Simone is gonna.
Hi. Okay, I'm Simone. I'm part of the Phantom community, and I have some questions from the Telegram group. So, it's not the bias. Okay, so one is Phantom looking into the possibility of building a DEX?
Yes.
Yes. Okay, the other one is they want to know more information about staking and hardware requirements for staking.
Okay, so staking, I can't comment much on. Hardware requirements is a function of the binary, so that I can talk about a little bit. So staking actually has a little bit of two models in that number one is we have this algorithm to be able to use memory and CPU testing to be able to ascertain the capabilities of a given machine. So we know the specifications by doing limit threshold tests. The more processing power you give to the network, the bigger your stake differential is. So the more reward you get for the hardware you're contributing. But at the same time, it's a proof of stake solution. It needs fast connectivity more so than anything else. And the consensus solution, because it's decoupled from the VM, doesn't actually do storage. So it itself is a few kilobytes that can run on a mobile device. So there aren't any hardware requirements, and you can still participate in the network, but you do add security then. But you will be better rewarded for providing better hardware.
I have one more, and this is, yeah, I know, sorry. I mean, there's supposed to be holochain guys in here too, but they're asking a question about Phantom. The last one is, and I know you're going to hate this because it's about TPS. Okay. So if you think that the TPS numbers from the testnet stress tests will be achievable on the mainnet, and is it even relevant, and what's your old thought about TPS? I added this last part.
Okay, so number one, do I think the current threshold tests in the testnet will carry over to the mainnet? Both yes and no. Assuming it is a good network participation and that each node is bringing transactions into the network, the transactional throughput will increase. It'll be more than we have now. If you have only one node originating and you have 10,000 other nodes that are sitting in disparate locations with bad connectivity, then it's going to be significantly slower than it is now. So the accurate answer to that question is it really depends on each node's contribution. The more, if I can call them leechers you have in the network, the slower it's going to be. The more contributors you have, the faster it's going to be. It's a network effect system. So the more contribution, the more value. What do I think of TPS as a general metric? I mean, let's face it, there's no standardized tests, there's no standardized implementation, so it's a garbage metric. I mean, one chain's TPS is 1 byte per second, and they transfer that between 5 nodes. Another's is a gigabyte big, and they transfer that over 24 hours with a terabit network. It is a complete garbage metric that you can't compare from one blockchain to the next unless there is standardized testing, which currently does not exist. Yeah. I mean, you could eventually design a standardized test. IBM Hyperledger is actually doing a project like that. That's actually quite nice. But you have to build towards their protocol for the test to work. So right now it's all like EVM throughput based. And if you're not EVM throughput based, well, you can't use the test. Sorry. So the stuff like that.
2 questions for Eric. So are you still on track for mainnet release this year? What can we look forward to from a product roadmap perspective? And number 2,
product what?
roadmap perspective. And then number 2, can you help explain the value proposition between behind HOT post swap. So basically the native token in the future.
Okay. Yes, we're on track for having OpenNet exist this year. Woo! And I mean, we're working on it. It's coming together. It's challenging. Rust has been challenging. It's also challenging for user adoption, but we're excited to use that language because it's so strongly typed that it'll allow us to create the security that we need in order for Holo to work and for Holo Fuel to work, which leads me into Holo Fuel. I don't know if we've already started shipping, but we're going to be shipping out actually for the first person, shipping out the Holo ports. We've started shipping out the Holo ports already. So like there's actually like physical things in the world that now exist so that you can run it, which is cool. And as far as the hot Holo Fuel relationship is that what we're set up to do is have you'd be able to swap back and forth hot to Holo Fuel and Holo Fuel back to hot. Originally, it was going to be you destroyed your hot when you turned it into Holo Fuel, but we've shifted it so that now you can go back and forth, and that Holo Fuel is going to be the currency. I got to burp, but I'm not burping it. That to pay for hosting on Holo's network. And just to be clear on how that works is that whatever business model a business has stays the same, right? For serving its web app to people online. Maybe it's a membership model, whatever, right? And that they pay that money goes to whoever owns that app. And then that app is being hosted by people who have server boxes who are running Holochain and Holo, and then Holo connects them to the person who's using their web app, right? So then that's the relationship, okay? And then the owner who's making the revenue from the membership fees, it's more fun when I draw this with pictures, that they're paying from their revenue for the hosting the same way they would if they were doing it not as a dApp, and then Holo takes 1% or less of a fee for the transaction for the hosting. So 99 or more % of what gets paid actually goes to someone who is providing that hosting at home, and the payment is in Holo Fuel. Yeah, that's how that works. And that's also what we're aiming and what we're like banking on being an actual land shift, is that the currency is so intricately tied to a usable asset that it will ultimately stabilize enough to create an actual stable market. Yeah.
Any others?
I just had a quick question for Andre. What will be the implications of quantum computing on the security of blockchains or DAGs? Where is the thesis coming from? Is there academic research on this?
Yeah, quite a bit actually. I released an article a while back that goes a little bit more into like which hashes are susceptible and where the dangers lie in. So there's a little bit of a current implementation of quantum computing, and then there's sort of the theoretical max implementation of quantum computing. So what everyone's afraid of is this maximum method of quantum computing, which can basically guess a private key for a public key instantaneously. But people always equate it to quantum computing. You give it a maze, and a traditional computer has to run multiple laps to try and get the answer. A quantum computer can just map all of them at the same time because it can switch all of the different possibility of bits and then arrive at the answer immediately. That is a much bigger risk to general EDCSA and all of the standard cryptography that goes with it, if that ever happens, which we technically don't have the physical implementation to support that, so we can't build that version yet. There are there's a subset of cryptography that specializes in specific hashes that aren't susceptible to brute force attacks or guessing like that. They do exist, so a lot of the different chains are moving over to that. The more current implementation is just a much faster brute forcing method. So it's not the super version, but it's still faster than general computing now. And while it's still at risk, even the quantum computers we have today to guess a standard private public key in EDCSA is going to take it at least 100+ years. So we're still not at that immediate risk problem with the solution. And by then, a lot of the standard cryptography can switch over to more secure hash systems. Pleasure.
Just a shout out to Andrew. I really love your code reviews. So thank you so much for doing that.
Awesome.
Most of that just goes over my head, but thanks to you and John and everybody at Crypto Briefing for actually doing that. So
awesome,
fantastic job. Yeah.
Awesome.
Yeah. And where's my Halo port, Eric? So thank.
It's been challenging.
Right.
I'm
Yeah.
out of China, and then they ended up getting check-this computers, which slowed the process down more. We tried explaining, no, they're not really computers, but they're like, we're not into your complex stuff.
Yeah. So I ordered a bunch of them when you guys started your. Perfect. Thank you.
I'll ask my other questions. For the block, this is for you, Andre, for the block propagation graph and everything like that, for the block size versus like time. For your example that you're giving, let's say like someone wants to order like a quantity of like 2 or 12 or 24, how will that impact like the block size and the time, like the efficiency to be able to like show that there is proof and everything like that? Would that impact anything by quantity?
Okay, can you just rephrase for me? I'm not following the question.
So for your example, you're kind of showing like just one checkout for one person. If there's like one person with multiple quantities of things, would that impact like the block size or like the time it would take?
So again, this is a lot about the originating entity. So if all of them are originating at the same entity, yes, it would impact it. I mean, the loads are still small enough that a single node proposing a single block could fit all of them in. But let's, for argument's sake, say this thing has reached a trillion purchases per second. If it all has to go through one node, eventually it would reach the size cap. That is the distribution between the network, and that will start causing latency issues. But in that case, instead of using one node, you'll simply split it between a few nodes so that you leverage each one. And then you end up leveraging the combined throughput. But yeah, if you use a single node, you're gonna eventually have a backlog cap.
Okay, so like also like on the graph and everything like that, after a certain point, it was like becoming more uncertain. So do you guys like work within like certain like operational thresholds? And then do you have to like kind of configure how you do block size over time to kind of equate for those uncertainties?
So what we're actually trying to do, this isn't currently part of the protocol, but the research we're busy with is building a network graph overlay, so that via standard transmission times, because we have this knowledge about knowledge graph that we're building, so we can use that to kind of detect how far a node is away from a given node or how close it is. And then based on that, if the network starts becoming bad, instead of adjusting the network itself, we actually have a network pruning mechanism that starts looking at these bad nodes and starts removing them out of the network to keep the node in an optimum condition for the configuration, instead of changing the configuration to adapt to a potentially bad network. So it's the secondary pruning layer that we're currently playing with. It's not fully implemented because it's currently very centralized, which we don't like. So there is still a sort of ungoverned, there's a governance adaptation layer, but that's voting based, not system based. So it could change the sizes, but then it's based on community vote. So it's not technically the same. So the second validator or observer layer is technically the best way to keep the network in an optimum space.
Very quick question again. I know Matt is very tight-lipped when it comes to any enterprises or any collaborations on the AMAs, but any updates on any collaborations like Mozilla or any other things that you guys have been working on?
So we've got a number. We're not tight-lipped on a bunch of the projects that we're in partnership that are building on Holochain, like Junto, RedGrid, Next Legal. We've got a few dev shops. There's like a handful. There's like a number of things that are in different stages. Just One Organics, Producers Market, Hum.Earth. There's some really cool projects getting put together. We're doing more work to actually share about them more and more. We've got more things coming out on Telegram, more spotlights, that kind of stuff. Yeah, there's no new news around like, you know, a Mozilla partnership or anything like that there. Yeah, we're in discussion with a small number of enterprises at the moment for stuff. Yeah, that I'm also going to be tight-lipped about. Yeah.
This is what I meant by tight-lipped. So.
Yeah.
Thank you.
Yeah.
For an entrepreneur, what are some of the key differences between IOTA and Holochain?
It's like, I guess it depends on the use cases that you want to do. I think that IOTA and Holochain has like distinct use cases, but I mean, who knows?
Such as
IoT is focused. IOTA is focused on like IoT. It's a lot of like P2P and working with like machines and devices. So it's kind of like a couple layers from the like the actual user itself. While I believe that Holochain at least is working on applications that directly impacts the as the human user.
So, and I'm not part of the answer, but just to kind of give it the thing about all of these layer 1/infrastructure chains is that's like, what's the difference between the different operating system? What's the difference between different phones? What's the difference between different databases? You know, they all facilitate the same purpose. Most of them look the same, function the same, act the same, but their niche in terms of their market development or their business development or their community development is normally a very specific vertical that's focused on a very specific domain area. So I mean, IOTA has this great transactional processing capability, which means the more devices that come into the network, the faster its throughput goes. So it's designed to have billions of IoT devices connected to it, and its niche is in that area and getting that information, not necessarily keeping it forever, but just processing it as fast as possible. Versus on the Holochain side, you know, it's a lot more about these extra communities and all of this extra stuff you can build with it. I mean, if everyone in this room wanted our shared social network, then we built that and we use that without needing to affect other systems. So one way I like to describe it, if you look at something like Ethereum, there's 900 different ERC20 tokens. Now, if one of them gets a lot of transactional volume, it affects all of the ERC20 tokens. If they were all designed on Holochain, then that one would get busy, but it wouldn't affect the rest. So that's a fantastic solution for these distributed consensus isolated products. And they're focusing specifically on the Holo product side, on the new decentralized web, which is focused around new standard of web hosting, a new way to present websites and interact with them, etc. So definitely their niche and their niche, but if you strip all of that stuff away, all of the SDKs and the APIs and all of that fluff, and you just look at the protocol layers, then it's, you know, what's the difference between Apple and Microsoft, or on the phone side, Apple and Samsung?
I just want to add one piece to it, which is, and thank you, that we do work well with IoT devices. Actually, one of the projects that I mentioned earlier is called RedGrid, which is a electricity sharing ecosystem, basically, that's getting built by this organization in Australia. It's pretty rad. And, you know, you can have a bunch of little smart meters connected to each little patch of solar cells saying that this is how much they're producing. And then each of those IoT devices functions as its own agent on the network. And you might even have little sensors in places that don't have the brain to do it, but they can take sensor data. And all you need to do is put like a Raspberry Pi or even something a little dumber than that, because Raspberry Pi is more than you need to run. We ran like 20 something nodes on a Raspberry Pi, right? To run a node, and just have that hooked up somewhere so that it's talking and then it functions as a user.
Then a follow-up in terms of other DAGs in the industry that are getting traction.
Other DAG-based solution that are getting traction. Avalanche is getting a lot of traction. They're a DAG-based solution. So again, DAG-based solution is difficult because, you know, you've got transaction-based DAG like the Tangle with IOTA. You've got consensus-based DAG like Phantom. You've got what's the other top 10 one? I always forget about Nano, which is a block latest type DAG. So So DAG as a nomenclature is common a little bit misused because the structure itself is used in very different ways in all of these projects. But the ones implementing some kind of DAG structure that are getting a lot of traction, I mean, IOTA, Holo, Nano, Perlin, Avalanche, Hashgraph. I wasn't that impressed with their code. But yes, Dispatch Labs as well, technically, but they're the same organization. Anyone else? What else is there? That's about the ones I can think of. No, I don't know them. But okay, so there's a few. I mean, it's and as the attention and the technology is developing, there's going to be more, and hopefully better ones.
I'll ask one more question.
You guys can leave whenever you want.
So do you foresee a sort of marketing craze that sort of kind of happened with sort of like the EOS and Ethereum battle?
From my personal perspective, I hope not, because there was so much noise and there was so much garbage going on that it was incredibly difficult to actually focus on the pure tech. Like I was reading so many absolute nonsense white papers to try and get to the one good one out of the 200 that are ICOing, versus now all of a sudden you only see the real like diamonds on the tech side that come out. So obviously from an investor or speculator side, that's a horrible thing to say, but from a technology side, the lack of hype is one of the best things that has happened. I think that's it. Oh wait, no, one over there.
I want to check in. Where's Dan? Dan?
No, we lost Dan.
Okay. All right. Cool. We're gonna take it. Keep going.
Teamwork. So you briefly mentioned that tokens on IDEXs are on DEXs are custodial backed, or like some type of tethered asset, correct? Is that necessarily true though for ERC20 tokens?
No, ERC20s are 100% controlled by Ethereum, and you own them 100%. So they are a true example of full custody. But the problem is that means that everything always has to live on Ethereum. Eventually, you'll want to trade stuff that's on EOS with Ethereum, with stuff that's on Bitcoin, with stuff that's on whatever other network you want to add into the equation. So that's why I meant true decentralization protocol, in that for it to be a true decentralized protocol, there has to be a cross-chain custodian mechanism that's not centrally controlled or managed. I mean, if you look at some of the base cross-chain guys, like right now, I think Wanchain's probably one of the implemented forerunners. But I mean, their Stormin are a semi-centralized method to get mapped assets onto their chain. So there's not yet this true decentralized mechanism. But blockchains are fantastic at controlling everything that's on the blockchain. So yeah, if you could get all of the assets just onto Ethereum, then Ethereum could be the platform for the one and only DEX. But we're going to see more and more chains come out with more and more assets.
Yeah, so if like Phantom's going to launch their own DEX, but it's a ERC20 token, how will that play out?
So the DEX specifically with Phantom that we're investigation isn't just us. So we're using the decentralized custodianship from Fusion, because they have that technology, just on the DCRM side. So that's a distributed key that can control via your account another account on another network. So how that works is my Fusion account can control my Bitcoin account via a decentralized key that's controlled by the Phantom network. So then instead of interacting with a map asset, you're actually controlling the downstream asset. And then the consensus side is what gives it the speed so that we can actually do the order book matching and the exchange matching. So it's a combination attempt.
Okay. All right, cool. Thank you.
We've got 3. We're going to have to take a stack in a minute. I want to just check in with you as well.
Yeah, sure.
So
How's
okay,
everyone feeling?
this.
You're getting bored? Do you want to keep going? Yeah. Okay, we'll keep going. A couple more questions.
Keep the flow.
Hi.
Just gotta check.
I have a question about I like the whole idea of the market cap bringing us back to the gold standard with a set limit. But if it's just I'll take the example with Bitcoin and the hard fork that birthed Bitcoin Cash, and then we saw Bitcoin Cash hard fork. How do we stop hyperinflation if we're just going to hard fork every time the demand or a massive upgrade needs to be made?
So to me, that's more, again, on the speculator side, because I mean, the the Bitcoin Cash fork and the Bitcoin SV and whatever else has come from that thing should never have happened. They didn't add to the ecosystem. They didn't improve to the ecosystem, and it was garbage cash grabs of people that just saw an opportunity and then went for it.
But they all three still exist.
And that to me is like Bitcoin Gold is still like top 50 or something. To me, that's insane. Like the team have literally admitted they are not working on it anymore and have abandoned the project. And yet,
well, we have the Lightning Network now, so there's no point. They're obsolete.
I have a lot of other comments on the Lightning Network.
To hear about that.
But it's a problem. But I think it's more of a speculator problem.
Oh, just one more, if you don't mind. Where do you see the future of privacy coins and regulation? Do you think that government will just do away with them entirely because they can't be?
So any regulated coin will probably not be allowed to be private, but there will always be room for private coins.
So no more XMR?
From a regulation side, no, and they won't be accepted as regulatory coins. So you'll have this regulatory asset class of coins that will be accepted, and you'll have the borderline ones that won't ever be accepted, but that won't mean they won't be used. They'll just, again, have their niche.
I have something on that. Right. So if you've been looking at like the Mimblewimble protocol and looking at like Beam and Grin and some of these like next generation privacy enabled projects, there's a distinction between being anonymous and being private. So there are a lot of projects like Zcash, right? They're talking about partial disclosure. So they're actually working pretty closely with the regulators and with these banks to say, hey, we've got this privacy enabling technology that will allow us to have components of our network be private. But then we can expose them, you know, based on regulation and based on kind of regulatory scrutiny. So I do think that they're like, I think private protocols will be regulated in, but I think there's, to your point, I think there's always going to be like something more private and something more devious that like will kind of be in the outskirts, like Grin. Maybe not Grin.
I think we've seen like the birth of a lot of stable coins recently. How do you see that playing out? Will there just be one?
Oh my God, I can answer that too. Wait, do you want to answer that? Stablecoin? So there's lots of different, I just did a report on this. So there are different types of stablecoins, right? There's there's like fiat-backed stablecoins, so Tether. There's also like crypto-backed stablecoins or crypto asset-backed stablecoins, and there's some that are regulated by like algorithms. So like Basis was gonna be like an algorithm-specific or like a tuned stablecoin. I don't know about you. I think that Maker is going to really win the day just because it's like decentralized, not because it's on Ethereum, but because it's this mechanism to kind of be pegged to something, but not be centralized. Because at the end of the day, when you look at these stable coins, it's kind of like you're giving up one devil for the other. Not saying like traditional financial institutions are devils, but like it's this idea if you don't trust them for X, Y, and Z, why would you trust like someone's just printing out their own money? I don't know. But I do think that they're going to play, but I think that the ones that you can like speculate on them, I think are going to probably have more interest. So yeah, right. So like Basis is one, they've got DAI, and then they've got Maker, which you can then collateralize the Maker tool. But then you've got like Radix. Does anyone know Radix? Yeah, Radix is funky, right? They're creating this like economic model where if you create more, so it's a stable backed asset, but it's backed by like their own algorithm, and it fluctuates based on supply and demand. But what's supposedly, they might have changed this, but what's really interesting is that if you're holding more of the, like if you're holding the asset and more is created in the system, you'll actually get some of that that's created. But if some is destroyed, you don't lose any. So there is kind of this interesting dynamic where you're getting value by participating in the stablecoin network, but you're not really speculating on it. I don't know. I feel like the stablecoins are just like, I don't know, stable. Yeah, they're here to stay, but I think that there's definitely gonna be certain ones that are gonna win out. I don't think it's gonna be like the fiat-backed ones.
I mean, I just had one quick follow-up question when you were talking about true decentralization. And if I understand it right, you're talking about like completely different blockchains where I may need to like either like be able to swap like two fungible tokens between two different blockchains, and or another thing that I was wrestling with is the idea of like non-fungible assets which have to be synchronized across different blockchains. Like this is sort of what you're talking about in these emerging truly decentralized algorithms.
Yeah, look, I think there's a real solution, and then there's kind of the current stopgap solution. Now, the current stopgap solution is just being allowed to have a layer above that allows you to talk and control all of the different chains. So an argument here, this is like let's say you built your own network a few decades back, and you invented a new communication protocol and you called it TDP for argument's sake. Now, eventually UDP and TCP comes along, and now you don't redesign your whole network, but you put a layer on top of that to allow the people above to interact with TCP or UDP and then to interact with your network. So that's kind of where we should get. But that needs specifications, that needs buy-in, that needs a consortium, kind of like W3C or anything else that we have, and that's still a little bit away. In the short term, because all chains sort of at least adhere to similar cryptography, so one sort of standard we have across them is ECDSA, and there's a few others we can add in as well. So by having distributed ECDSA at least, it means that I can have single control over multiple chains and actions. So doing this allows a if this then that scenario. So I can say if 10 B2C arrives in my Bitcoin wallet, then trigger this Ethereum smart contract to issue these to the Aon network, for argument's sake, because all of them use ECDSA. So this one rule that I set can control it in all of the different chains. So that's sort of the start, but that's not where it's supposed to be. It's supposed to be at a point where there's actually a protocol of communication between the chains. But getting that's going to be a lot of hard work, because right now we still have this philosophy. Well, most of the companies have this philosophy of there will be one chain to rule them all, which is just bullshit, because I mean it wasn't true for any industry in our world, so it's not going to be true for this one. But they're still functioning on that principle. So interconnectivity and communication is still sparse at best. So we're kind of starting with the one commonality, which is at least the cryptography side, but it should actually be on a protocol layer, something like the actual P2P communication or RPC worst case scenario, and not the cryptography side.
And you can sort of create sort of almost like a meta super contract that is executing things across two, make sure that something is executed on one blockchain and executed on the other, and validated that they both occur, and then come back and say, okay, everybody's good. So
that's the current implementation, but that's not how it should be. These chains should actually be able to interact with that. So when that happens on Bitcoin, it should have a protocol that allows it to interact with Ethereum to be able to do the next step instead of this thing on top. So right now we're doing it with this thing on top, but I want to
custodial thing. It's effectively you have to both private keys and both sides to do something.
But the chain itself does it in a completely distributed and decentralized manner. So it's sharded across all participants. It's resharded with subshards if new participants join or existing one leaves, as long as you still have majority threshold to create the key, and then it allows it to control it that way. And you're just a shard owner. Then by virtue of owning the shard, you can initiate any of these transfers or transactions. But that's not where I want it actually. Where I want it is on the P2P level. So they're all communicating and sharing that data, and you selectively decide what you consume or what you act upon based on specific codes or signatures or something like that. That's a much better solution, and this is currently just a hack to get it working.
You mentioned snark, by the way. What were the two other things that you mentioned earlier?
So bulletproofs, snarks, and starks are the three primaries in this space.
One more time.
Bulletproofs. And then the other two are very closely related. So snarks, the original adoption was actually by the Zcash team, and a lot of their original designers developed this new protocol, Starks. So it's just from snarks to starks, and they're actually launching Starkware, which is built on the Stark protocol, to be their new privacy coin. So those are the two main ones, snarks and starks, and then the last one is bulletproofs. But if you send me after this your Telegram or something, I did a whole paper on there's 20 different ones of them, so I can share them all with you.
So one more, and mine is actually not really a question, but as with any technology, you can use it for good or evil. I know today's talk is more focused on the technical aspects of it, and with this technology, I think most of us can agree that is to build a better economic system. Maybe some call it near utopia, whatever. Can you guys just touch a little bit on what your vision is if this becomes a success, so to speak? What is this utopian world going to be and if it's not the fail state, what would that be? What would be the consequences?
Look, if I had the choice, I'd definitely use it for evil. I just don't know how to use it for evil. I'm not sure how you would position it to be able to maximize that. I'm going to cycle it around and then let it come back to me, but I'm going to figure out a way how we can use it to be super evil.
Fine. I think that there's the potential in it for a phase, like a epochal shift in our capacity to interact with each other and coordinate. Like right now, like to actually, first off, I don't think it's going to be utopian. We've totally destroyed the planet to the point where like we are committed, basically, like biologically, ecologically, like planetarily, to a dystopian world for a while, right? But that in order for us to be able to start doing things differently, just having personal value commitments isn't enough. We need to actually be able to coordinate, and we need newer ways to coordinate, and we need to be able to recognize different flows. So we just need a capacity shift, the way that reading is a capacity shift, or reading and writing are a capacity shift, or like a moving image is a capacity shift. So I see these technologies as having the potential for us to use to interact in ways that allow us to step into what I personally believe is our like role as a species, as like nurturing life on the planet and stewarding it, and instead of just eating it.
I think the problem with our society is that we have a culture that's rooted in a sort of like profit-centric mentality, and that's not sustainable, you know. And I think one of the ways that might help is to talk about, how to create a model that's not focused on profits. Because even today, the crypto community, they're all, entrepreneurs come in and they're like, oh, well, how do we make money from this technology? How, I guess that's one of my concerns.
So I had something really interesting in a forum. They were like, at the end of the day, what are these really? They're like distributed databases, right? So the kind of like hard reality is that the reason that why people are so interested in this in the first place is because there are economic incentives. Like, so it's kind of hard to break those two. Like, hopefully, like, I'm not saying that Phantom and IOTA aren't like, very altruistic, but Holochain and like, there are these projects that are trying to say like, we don't really care about the token. We're trying to have like non-token based models. Like, I think they exist, but I think that idea that like, whenever you hear someone on a forum be like, I'm only in it for the tech, it's like, are they really in there for the tech, or are they like there every hour of the day because they're like incentivized to do it? Yeah. So, I mean, I don't know. It's a weird balance, but hopefully.
Okay, I stole it. I'm gonna add something on that. And so to me, just the fact that the technology is here, it's good enough to tell us that it's gonna stay. And of course it's gonna evolve. And if you try to do a sort of an imagination example, and you think about how the world is going to be in 100 years, are we still going to use paper stuff not only for money, which is already not happening, but what about identity? Are we still going around with our plastic cards or paper cards, showing our data to everyone and stuff like that, and doing crazy line at airports? I really don't see that happening. So we're going, a little bit fast further in the future. It's not going to happen in a year or two, but I think this is at least the base of. Exactly. Yeah. Yeah. And about the speculation, I think that's actually a really good sign that we got something good here. Same thing happened with the internet. At the beginning was, kind of, it was used, as we all know, the primary uses of the internet in the 90s were porn and evil stuff, and then big boom, big speculation, and that meant something. And then after that, we got to a world that we cannot live without the internet. So I think the same thing is going to happen for blockchain.
Very nicely said. Yeah, well done.
I think that you guys really covered it, a lot of it. So I don't have too much like specific stuff to add, but it's more about I guess it's just like the empowerment especially those that don't really have the opportunity. But then if we can have the like technology as like a means, or as like a tool for accessibility to give you the opportunity to actually like move forward. And I think it's the ability for these these technologies to actually help people, like it's like empowerment and growth for like more people. That's if they choose that path, but it gives them this option.
Awesome. Well, thank you. Thank you so much for coming, everyone. I want to thank Kevin and Eric and Andre and Simone. They did incredible. Thank you so much for being incredible partners in this. And yeah, we have the next one tentatively for first week of April. I'll let you know. I'm not going to say who it is yet, but I think we have one or two interesting people.
We want to say thank you, Dan, and Protocol NYC for putting this together and bringing us here and hosting this. So thank you for that.
I hope it was valuable. And then I think, again, the most important thing is connecting. I try and put some time together. So we've got about 20 minutes, but before you go, you should connect with each other because we're all really interesting people.